This is Professor Derek Seitz. This is part 2 of the Java Inheritance tutorial. This part focuses on the base class. Quickly reviewing from part 1, we looked at a class diagram where boat was the base class and it had 4 derived classes: canoe, motorboat, rowboat, and sailboat. In this tutorial we're going to focus on the base class, boat. Here we have the code for the boat base class. The first thing to keep in mind about a base class is that it is a class. As such, we need to hide its implementation as much as possible from external entanglement. External being its API, its public interface. We can think of this kind of coupling as horizontal entanglement. Think about what needs to be public. Fields should not be public. We should use getters and setters to provide access to the private fields that we want to be known about. We see here the fields: depth of hull, length of hull, width of hull. All these fields are private. There's one field protected for illustrative purposes, and in the functions or methods below we have provided get and set functions to access and update those fields. However, since this boat class is a base class, we want to also hide its implementation from derived class entanglement. You can think of this as vertical coupling, vertical entanglement. We need to think about what needs to have protected access, which makes it available to child or derived classes. Fields should not have protected access. We rather would use getters and or setters to provide access to private fields. We need to plan for inheritance. Think about what should be reused in a derived class. This boat class, in the planning of it, needs to consider the different derived classes that it's going to support and what kind of functionality it wants to support reuse of. We should also think about what needs to be specialized in the derived classes. What functions will they override? Failure to plan will result in either a rigid class where we're stuck with inadequate design because we have classes out there that are using things that we've exposed, implementation details, we violated encapsulation, and now we're stuck because of our kind of contracts of what we released. Or on the other hand, it may need rework because it really wasn't suitable to support the needs of derived classes. Looking through the code, we see the protected member, the private members. Here is a constructor that takes only a string, the name of the boat. The boat itself is a very minimal boat. It's a hull, the part of a boat that floats. The depth of the hull, the length, and the width of the hull are fields. The number of anchors, the material that the hull is made out of, the name for the boat, the specific boat, and a category, in this case, boat. This simple constructor, the name only constructor, you can supply a name and not supply the other measurements for the boat. The fuller version, multi-parameter constructor right here, the name and the 3 measurements for the hull. They are set here in the body of the constructor. Notice there's some warnings here. we're calling our setter functions, such as set depth of hall. The reason we're calling our setter functions is because they have validation in them to protect the state of the class from an invalid state, such as here we don't really want the depth of the hull to be less than 0. 0 here might indicate that it was not specified, but less than 0 would not make any sense at all. So that's why we call the setters. However, with inheritance, things can get complicated quite quickly. Notice the warnings over here. It says an overridable method call in a constructor. Set depth hull, it's not saying that it has been overridden by a child, but since it's public, it could be overridden by a child. And when that happens, it would create a complex scenario where a child class constructor, as we'll see, will call the parent class constructor first. And then this method could be called, and if it was overridden, it could make a call to a child class overridden function when actually the child class has not been completely constructed yet because its constructor has not finished. Now that sounds very complicated, and it is, and I don't want to go on a tangent here, but needless to say, you have to be careful with inheritance because it's fundamentally a more complicated structure. The hint here gives various options. I'm going to take the option to make the method final, which means it will not be able to be overridden by a child class. I'll do that for each one of these. Set the method to final. It will change the code when we get down there. It'll be final. And the warnings go away, and we don't have to worry about that scenario. Display specs is a public function. Notice the annotation over here. It says it is overridden. So this function is overridden in child classes. It does a system out print line passing in this. Print line needs a string. This is a pointer to the object for this base class, and that will end up calling this toString. We'll see that later on in the code. The next thing is a couple of draw functions where we draw a side view and draw a top view. All the output from this base class goes to the system console. Notice it's a simple hull here from the side view and a simple hull from the top view. The getter functions for the fields, get category, get depth of hull, get hull material. Down here, notice there's a note. There's no set category because it was made for illustrative purposes. It didn't have public or private. It was protected access, so it can be directly accessed by child classes. The setters do some validation to protect the state of the class. And also notice that these draw functions are also overridden. You see the icon there that they're overridden in the child. So display the specs for the boat, the drawing, top and side view. These are things that will be different for different specializations of a boat. For the canoe, it's going to look different. It's going to have different specs. So these we would expect and should plan for that they would be overridden. Continuing on down. Down at the bottom we have the toString, which simply prints out in a string the various values and labels for the fields. Notice that the toString has two annotations, multiple annotations. One is the fact that it is overridden in child classes. Another says, do you want to add this @ override annotation? That's something we're not going to do, but that annotation, if it was added, the compiler would enforce that this toString that we have here, which is actually overriding the toString in the object class, which is the base of all the classes in the Java class library, it would enforce that it was spelled correctly and had the right parameter list. Finally, we're going to go look at the client of this base class that uses it, and we can see that also up here the boat class itself says it has subclasses. The boat base client has the main method here, and it instantiates a boat called unmeasured hull boat. It uses just the name constructor. Then it displays the specs for the boat and draws the side view, draws the top view. Notice that the other formatting to help the output is not part of the boat class. It's added here in the client. That makes the boat class more reusable in different contexts. Then we do a boat 2 with a multi-parameter constructor and do its display specs. And finally we try something. We take boat 1, and since it's a protected field, and protected fields are accessible, directly accessible by all classes in the same package, including this client, which is not a child, we change it to airplane and see what happens. Let's go ahead and run this and look at the output. Here we see our first hull boat with all the other parameters being 0 because we just did the name. It does the side view, the top view. Here's the multi-parameter boat with its specs, and down here when we changed the category and printed it out, sure enough, it allowed us to change that. So that's something to watch out for with protected fields. But as long as you're in the package that you're designing, you have control over that. So that's a design decision that you'll have to look at. But here we see the output from this basic hull boat. Especially here the pictures give us that it's a very minimal boat. In the next tutorial, the third part, we'll be looking at the derived class code in this inheritance hierarchy.